She's confident. Oh no no. Oh no no. She's confident. Oh no no. Oh no no. And I'm down with it. Oh no no. Oh no no. She's confident.
Hey, a little unknown Justin Bieber. At least I didn't know it. Whatever. Back to confidence intervals. Wanted to catch you guys up on some of the notes. We got a little off task last week, so we got to catch you up. So if you have your notes out, that would be awesome. If you don't take them out, you can always pause the video and just, do what you need to do and then get caught back up. So at the top of this page, we have a little chart, and this is going to be important more later on than it is right now, but when we talk about a confidence interval, we have to set a particular percentage that we want to be confident at. Most of the time, we are going to be using the 95% confidence interval, but our book is going to give us a bunch of different options, weird ones like 99.8 down to 70, and then later on we can actually use our calculators and get even more confidence levels. But right now, we are going to be talking about this Z star from the formula. And Z star, remember, is the number of standard errors you want to go out from your p-hat value to generate your confidence interval. And that's what the confidence level and the Z star values tell you. So we're going to be doing 95%. And if you remember from the empirical rule, typically the number associated with 95% is 2 standard deviations. In fact, it's really 1.962, but we round it to 2 just to make life easy, and because decimals just get in the way, for right now we're going to be using the approximation of 2 when doing the 95% confidence interval. So in the problem that we're going to do, we're going to generate a 95% confidence interval, but instead of using 1.962, we're going to use 2. All right, flip the page. Well, I'm going to flip the page. I guess you guys just have to look down on your page. All right, so here's the example if you haven't read through it yet. The yogurt bar proposal for Amity High School. So a survey was taken of A, B, and C lunch students, found that 33 out of 94 were in support. We want to generate a 95% confidence interval and then interpret what it means. And the first thing I have to say is I've made a small mistake here in your notes. It says, what is mu of p hat and standard deviation of p hat? That was last week. This week we're going to get rid of those, and we're just going to generate p hat, and instead of standard deviation of p hat, we're going to generate standard error of p hat. And you have the formulas for those already, but just in case you forgot, p hat is just x over n, and standard error of p hat is the square root of p hat times q hat over n. So in this particular problem, we want to find p hat. So p hat is x over n. In this case, x is the number of successes, 33 out of 94. So p hat is 33 out of 94. And remember that we're going to go 4 decimal places on this, so 0.3511. So our best guessed estimate, our point estimate for the true proportion is about 35%, 0.3511. Our standard error of p hat, is found by taking the square root of that number, p hat, 0.3511, times q hat, the complement of that, which is 0.6489, and then dividing by our total sample size of 94. Rounding that to 4 decimal places, you should get 0.0492. So again, our best guess estimate, 35.11, so 35.11%, with a error measurement, our standard error of about 4.92%. So there is some variation that we expect in our sample. So that's part 1, generating the values that you're going to be using. Part 2 is our ISIS check, so our independence check. Do you believe that student views, when asked randomly at lunch, would be independent of each other? And I think that there should be no reason why we believe that they're not. Just randomly choosing a student and asking them if they want a yogurt bar should be a fairly independent response. So that is good. Our second thing that we're looking for is this an SRS? So are the 94 chosen students chosen at random? And it says that it is a random sample. So rarely does it say simple random sample. So random sample is given to us. So yes, we know that this is a random sample, 2 for 2. The second I is really, we know, a 1. This is the 10% rule. Is n greater than or equal to 10 times little n? So is the population of students in A, B, and C lunch greater than or equal to 10 times 94 or 940? And everyone's supposed to go to lunch. I know they all don't. I see you guys sitting out in front of the library or hanging out in other places like, I don't know, the bathroom, which is really weird, but whatever. N greater than or equal to 940, yeah, all 1,600 people are supposed to eat lunch, so I'm fairly confident on that one. And then the last one is going to be our success failure. So our last S is success failure. And in this case, successes are NP hat and failures are NQ hat. So the people that said yes to the poll, which is 33, and the people that said no to the poll, which would be 61. So you don't really need to calculate anything, you just need to do a simple subtraction. NP hat will always be the number of successes, so the 33, and then NQ hat will be whatever the sample size is, N minus whatever the successes are. And we're looking for both of these to be greater than or equal to 10, which they are. So we have met all 4 requirements for normality, which means that, again, we can use a confidence interval that is based off of a Z star value, because Z star is directly tied to the normal distribution. And that's the importance of that. So we're good to go. Let's move on to the next part. So on to generating the actual interval. I'll do a little review with you here. Remember that our confidence interval is our point estimate P hat plus or minus our margin of error. And our margin of error is Z star times the standard error of P hat. Again, not standard deviation, standard error. We just generated these numbers on the previous page, so we have all of them. Our P hat is 0.3511. For this example, we're using Z star as 2 because that's the number related to 95%. And then the standard error calculation that we had was 0.0492. That would be 0.3511 plus or minus, so 2 times 0.049, I forgot the 2. 0.0492 is 0.0984. So that 0.0984, that's your margin of error. So if you're specifically asked to calculate margin of error, you're just calculating that number. Generally, we calculate the p hat with the margin of error and then write the interval. So the interval that I would get would be 0.3511 minus 0.0984, which I get is 0.2527. And then the upper value, when I add the margin of error to the p hat, is 0.4495. You should make sure that you can do all of this, but again, there's nothing difficult here. It's more or less just understanding what the formula is and how to plug the values in. No really difficult math. And then finally, we have our interpretation of the 95% confidence interval. Sorry, I had to do that. Every time I see the statement "we are," I think of that song. So when we go ahead and interpret our confidence interval, we always start out with the phrase "we are," kind of not a first-person response, because this shouldn't matter. It should be the exact same interval for every single person in the class. So it's not just that you're 95% confident, but we are 95% confident. So we are 95% confident. So that's what we are. We're 95% confident that what? Well, we're trying to pinpoint where the true proportion of students who support a yogurt bar fall. So we're 95% confident that the true proportion of a specific population, and in this case we're talking about Amity High School students, that support a yogurt bar falls between the interval that we calculated. So falls somewhere between a low value of 0.2527 and a high value of 0.4495. So we believe that the true proportion is somewhere between about 25% and 45%. And this is based on a particular set of circumstances the most important of which is a sample of size 94. So based on samples of size 94. Again, I say samples of size. We only took one sample, but if we did this over and over and over again, we would expect 95 of the 100 samples to pinpoint the true proportion somewhere in this interval. So that's how we interpret it. We get our confidence value in there. So we always say what percent confident we are. Let me get my little pointer here. Here we go. 95% confident that what we're looking at a true proportion of some particular group, Amity High School students, that are, and what's the context of the problem? At this point, we're talking about supporting a yogurt bar, falls in our interval based off of our sample size. So we'll be looking for all of those pieces every time we write a contextual conclusion. If you just say the interval is between 0.2527 and 0.4495, you really haven't told me much. You've just told me an interval that doesn't make any sense because it has no context. All right, there's a second video for you guys to watch, the Colorado example, so make sure that you watch that one and get those notes, and then make sure you get to work on those worksheets. We'll see you tomorrow. Bye.